In this video, we're going to focus on simplifying nth roots of monomials. So the first example I have is the cube root of negative 27x to the fourth, y squared. I'm going to break it into the cube root of negative 27, and then I'm going to do the cube root of x to the fourth and the cube root of y squared. Remember, cube roots mean that you are looking for sets of 3. Now, if I take the cube root of negative 27, 27 is actually a perfect cube, and negative 27 is a perfect cube even of negative 3. If you have a negative to an odd root, we can just take the negative out, and 27, if I just deal with positive 27, is 9 times 3, and 9 breaks into 3 and 3. So I have 3 3's, so I can take out a negative 3. And so there is my first number outside the root. Now remember the shortcut that we've learned before is I want 3 x's to pull out, but I have 4. Well, that means, fourth power, I have x times x times x times x. I have one set of 3 x's. So I can pull out 1x, and I have 1 remaining inside. So I have the cube root of x. Y squared means you have 2 y's. I want to pull out a set of 3. I don't even have 3, so the 2 y's, which is y squared, stays inside. When we were dealing with simplifying square roots, what we did was looked at in a way division and remainder, and the same thing can be used here, the same shortcut. How many times does 3 go into 4? It goes in there 1 time, so we pulled out an x to the first. Well, you would have 1 remaining, and so 1 remain. How many times does 3 go into 2? It doesn't, so the 2 actually remain inside. So there is a shortcut just like with simplifying square roots. So we're going to try that on the others that we're working on here. So we have the fifth root of 32 quantity x plus 1 to the seventh. So I'm going to break it apart so we can look at them separately. Fifth root of 32, and I have the fifth root of x plus 1 to the seventh. Well, fifth root of 32, I know off the top of my head is 2. But if you want to break it down, you can see that 4 times 8 is 32. 4 breaks into 2 and 2. 8 breaks into 4 and 2. And then 4 breaks into 2 and 2. You have 1, 2, 3, 4, 5 2's. And that's what we want, is we want a set of 5. So I can pull out 1, 2. And if we take a look at this, let's try the shortcut. It doesn't matter that we have a plus sign here because the parentheses is being raised to the 7th power. So I want 5 of these parentheses. Well, how many times does 5 go into 7? And it goes in there 1 time. What remains? Well, if I have 7 x plus 1, 7 of those parentheses, I take out, the 1, which means that a set of 5, there should be 2 remaining inside. So my final answer is 2 times the quantity x plus 1 times the fifth root of x plus 1 squared. And so looking at that whole division and remainder of the root and the power allows us to use a shortcut for simplifying nth roots. Number 3, we now have a number on the outside, 20 times the fourth root of 16 times the quantity 3x to the 8th. So let's focus on this. That 20 is going to be multiplied at the end. I'm going to keep that for the end. Make a note, I'm taking the fourth root, which means I'm looking for sets of 4. So let's do the fourth root of 16 and the fourth root of the quantity 3x to the 8th. Well, I know off the top of my head what the fourth root of 16 is. The quickest way to do the fourth root is to take the square root, which is square root of 16 is 4, and then take the square root again, which is square root of 4 is 2. My personal opinion is you should probably know 2 to the first power, 2 squared, 2 cubed, 2 to the fourth, and 2 to the fifth off the top of your head. If you don't, then just split it apart. We're looking for sets of 4. 16 is 4 times 4. 4 breaks into 2 and 2. And so I have one set of 4, and that number is 2. So I can pull out a 2. Remember that 20 is on the outside, so I'm going to bring it down so I don't forget about it. And now we have the fourth root of our quantity, 3x to the 8th. Remember, it's the entire parentheses being raised to the 8th power. So we just need to know how many sets of these parentheses do we have? How many sets of 4? Well, take 4. How many times does 4 go into 8? It goes in there twice. So that means you can take out 2 of those parentheses. And nothing's going to remain because it goes in there evenly. And now it's about simplifying. I have 20 times 2, and 20 times 2 is 40. And then I have 3x, that quantity squared, which is 3 squared is 9, x squared. And so I get 360x squared. And so even with fourth roots, the shortcut works. Let's look at example number 4. Just like before, we have a number on the outside, 3. That means we're going to take that in consideration at the end. I'm going to make a note that we are looking at the fifth root. So I'm going to break it apart. I have the fifth root of 243. I'm going to keep all the variables together this time since we know the shortcut. And so a to the 10th and b to the 15th inside the fifth root. So what's the fifth root of 243? Well, you can type in your calculator fifth root of 243, or you can break it apart with prime factorization. 243 is 81 times 3. 81 is 9 times 9, and each 9 breaks into 3 times 3. And so since I have the fifth root, I want 5 of the same number in order to pull it out. And so I have 1, 2, 3, 4. I have 5 3s, and nothing remains. So I can take out a 3 from this fifth root. Now we still have to remember there's still this 3 on the outside. So that's going to come down and be multiplied. And now I'm going to be dealing with the fifth root of a to the 10th, b to the 15th. Well, let's try the division shortcut. How many times does 5 go into 10? It goes in there twice. And nothing remains, so everything comes out. How many times does 5 go into 15? 3 times. With nothing remaining, so everything comes out. And then we simplify. You have 9a squared b cubed. And so far we've been dealing with roots. For the most part, we've been dealing with nice ones. Everything was able to be pulled out. Sometimes you'll have some remaining. So the question is, how do you take the fourth root with your calculator, and how do you take the fifth root with your calculator? And we're going to examine that in examples 5 and 6. In example 5, we are dealing with a cube root. And so I'm going to make a note of that. Usually I do it by circling, so I know I need sets of 3 in order to pull out, and then let's split it apart. You have the cube root of 8 times, and I keep all the variables together since I know the shortcut, cube root of c cubed d to the 12th. And so as I said, we can do prime factorization with 8 and see how many numbers now it's in that come instead of 3 to pull out. But we also need to make sure, can we use our calculator? And so the question is, how do you take the cube root of something in your calculator? Now, you do have a cube root button in your calculator, but it's a little hard to find. You have to go to Math. And if you look at number 4, you have cube root. If you look at number 5, you have x root. And so we have a square root button and we have a cube root feature, but we don't have a fourth root, fifth root, sixth root. And so I'm going to use, now I could use this cube root button, but I'm going to come back and I'm going to use option 5. We'll do, cube root first. So I have the cube root, of 8, and I hit enter, and I know it's 2. But what if it were 4th root or 5th root? How would you go about that? And so what we're going to do here is we're going to hit our 3 math and then go down to x root. And you'll see it would automatically take the cube root of the function for it. And so that's how you would do 4th root, 5th root, 6th root, etc. is type the root first and then go to math and choose option 5, x root. And so I know now that the cube root of 8 is 2. And so let's try our shortcut technique for the variables. How many times is 3 going to 3? It goes in there once with nothing remaining. So 1c comes out, nothing's inside. How many times is 3 going to 12? It goes in there 4 times, so d to the 4th. Nothing remaining, so everything comes out. And so my final answer is 2cd to the 4th power. So in number 6, I have the square root of 196. I have the square root of c to the 4th, d to the 6th. So 196 is actually a perfect square of 14. Square root means you're looking for sets of 2. So how many times does 2 go into 4? It goes in there twice perfectly. How many times does 2 go into 6? It goes in there 3 times perfectly. So my final answer is 14c squared d cubed. And so that is how you simplify nth roots of monomials. You still apply that shortcut. You look for however many sets there are based off of your root and simplify from there. And we also were able to look at how do we take nth roots and cube roots in our calculator, which is located in the math menu in your calculator. Number 5 is x roots, which is nth roots, and number 4 is cube roots for this.